There are aircraft engines that changed aviation. And then there are engines so extreme, so powerful, they sound almost impossible in reality. The Soviet NK-12 turboprop is one of those engines. It powers the legendary Tupolev Tu-95, an aircraft so loud that NATO's submarines reportedly detected it underwater. Even today, more than 70 years after its first flight, the NK-12 remains the most powerful turboprop engine ever put into mass production. 15,000 shaft horsepower, counter-rotating supersonic propellers, near-jet speeds using propellers, and engineering solutions decades ahead of their time. But what made this engine so unbelievably powerful, and why has nobody truly surpassed it? To answer that, we need to investigate one of the most ambitious engine programs in aviation history. The Soviets needed something impossible. At the end of World War II, the Soviet Union faced a terrifying problem. America was advancing rapidly in strategic bombers. The US had the massive Convair B-36 Peacemaker and was already developing jet bombers like the Boeing XB-47 Stratojet. Meanwhile, the Soviets were still relying on the Tupolev Tu-4. It was essentially a reverse-engineered copy of the American B-29. That was unacceptable for Stalin. The Soviet Union needed a bomber capable of reaching North America, and the viable option was jet engines. But there was a major problem. Early jet engines were terrible on fuel. Turbojets in the late 1940s consumed enormous amounts of fuel and lacked the efficiency required for true intercontinental range. Air-to-air refueling was still primitive, so Soviet engineers faced a brutal engineering dilemma. How do you build a bomber fast enough to survive, but efficient enough to cross continents? Their answer was crazy: the German connection. In 1945, the Soviets captured hundreds of German aerospace engineers. The Soviets moved many of these German experts deep into Soviet territory along the Volga River. There, special design bureaus known as OKB were created to study and improve German engine designs. These scientists had worked on advanced engines like the Junkers Jumo 004, BMW 003, and their mission was to develop the next-generation aircraft engines for the Cold War. Initially, they worked on turbojets, but then Soviet leadership issued a shocking requirement: build a turboprop engine producing over 12,000 horsepower. At the time, this sounded nearly impossible. Most turboprops of the era produced only a fraction of that power. The engineering barriers were enormous, and the biggest problem wasn't the engine. The main problem wasn't actually the turbine, it was the propeller. As propellers spin faster, the blade tips begin approaching the speed of sound. Once the tips become supersonic, shock waves form, efficiency collapses, noise skyrockets, drag increases dramatically, and the propeller can literally begin tearing itself apart from aerodynamic stress. To produce massive thrust, engineers usually increase propeller diameter, but bigger propellers meant even faster tip speeds. The Soviets were trapped. They needed enormous power without giant, inefficient propellers. So Kuznetsov engineers developed one of the most radical aviation solutions ever attempted: a contra-rotating coaxial propellers. Instead of one propeller, the NK-12 used two propellers mounted on the same axis, spinning in opposite directions. Each had 4 blades. This solved multiple problems simultaneously. Firstly, the rear propeller recovered rotational airflow energy wasted by the front propeller. That dramatically increased efficiency. Secondly, the engine could absorb much greater power without requiring absurd blade diameters. Thirdly, torque cancellation improved aircraft stability, but mechanically, this was a nightmare. 2 massive propellers, complex reduction gearing, extreme torsional vibration, gigantic loads on bearings and shafts. The gearbox became one of the most difficult engineering challenges in the entire program, and early designs failed catastrophically. The disaster that changed everything. The first approach was crude but logical. Engineers attempted to combine 2 existing turboprop engines into one shared gearbox system. On paper, it worked. In reality, it was unreliable. But on May 11, 1953, The first Tu-95 prototype crashed during its 17th test flight due to catastrophic gearbox failure. While several crewmen successfully parachuted, legendary test pilot Alexei Perelay and 3 others were killed. This became the defining forensic moment of the NK-12 program. The Soviets realized they needed an entirely new engine architecture, not a modified engine, a purpose-built monster. So Kuznetsov's bureau designed the TV-12, later renamed the NK-12, and this engine introduced engineering solutions decades ahead of their time. Inside the NK-12. The NK-12 was fundamentally different from Western turboprops. It featured a 14-stage axial compressor, 12 can-annular combustion chambers, a 5-stage turbine, massive reduction gearing, and contra-rotating propellers. The compressor achieved efficiencies around 88%, while the turbines reached around 94% efficiency. Even today, those numbers are incredibly impressive for a turboprop engine. One key innovation was the variable inlet guide vanes, these adjusted airflow angles entering the compressor. That prevented compressor stall at different power settings and altitudes. The engine also used hydraulically controlled bypass valves. These managed excess airflow during operation. The compression ratio varied dynamically between 9:1 and 13:1 depending on altitude and engine conditions. That was extremely advanced for the 1950s. This also dramatically improved fuel efficiency, and the results were astonishing. The insane numbers. The NK-12 generated about 12,000 shaft horsepower. Later, NK-12MA versions reached roughly 15,000 shaft horsepower. That's a total of 60,000 shaft horsepower. Powerful enough to power a small town. That remains unmatched by nearly every turboprop engine ever built. For comparison, the Europrop TP400-D6, used on the Airbus A400M Atlas, produces around 11,000 horsepower. The Progress D27 reaches roughly 14,000 horsepower, but the NK-12 achieved this in the 1950s, and it was incredibly fuel efficient. Its specific fuel consumption was dramatically lower than comparable Western turboprops. That efficiency allowed the Tu-95 to achieve extraordinary range while cruising near jet bomber speeds. The aircraft could reach approximately 920 kilometers per hour. That's astonishing for a propeller-driven aircraft weighing nearly 190 tons. The NK-12 essentially pushed turboprop technology to its absolute physical limits. There was, however, one major side effect: noise. The propeller tips approached supersonic speeds during cruise. It can travel at around Mach 0.7. At this point, portions of the blade tips generated intense shock waves. Those shock waves created the infamous acoustic signature of the Tu-95. The aircraft became one of the loudest military aircraft ever built. Crew fatigue was severe. Submarines reportedly detected the aircraft acoustically from underwater. They could hear it before detecting it on sonar. And NATO pilots could sometimes hear the bear before seeing it. Ironically, that deafening noise was evidence of the engine's incredible efficiency and power. The NK-12 was extracting enormous thrust from airflow that ordinary turboprops simply could not handle. The engine that refused to die. Most 1950s engines disappeared decades ago. The NK-12 did not. It still powers modernized Tupolev Tu-95MS bombers today. It also powered aircraft like the Antonov An-22 Ante, Tupolev Tu-114, and even the bizarre Soviet Ekranoplan known as the A-90 Orleanok. And despite its age, few engines have ever matched its combination of power, reliability, range, fuel efficiency, strategic usefulness. The NK-12 wasn't just a successful engine, it was the absolute peak of turboprop evolution. Conclusion. The NK-12 exists because Soviet engineers faced an impossible challenge. Jets were too inefficient, piston engines were obsolete. So they forced turboprop technology beyond what anyone thought possible. The result was an engine so powerful, its propellers flirted with the speed of sound. So efficient, it kept strategic bombers airborne for continents. And so durable, it still flies more than half a century later. The NK-12 wasn't merely powerful for its era, it remains one of the most extreme aircraft engines ever created. Thanks for watching. Comment loud if you think the NK-12 was a masterpiece, and we'll see you in the next one.